Good day, class. It's been a long time since we met, and I know everybody is doing very well. And you have been visiting your LMS platform to see what is there. I put a couple of things there, and I believe everybody has gone there to download and is going through the material. I'm picking the last topic. I want to treat it uh, uh, through video. So I'll send you the video and I'm done. I'm going to treat Octave stroke Matlab. So that is what I'm going to explain to you so that when you go through the notes, you'll be able to appreciate and be able to practice. So let's start. Let's get started. Computer application for teaching and learning mathematics. And we are considering Octave and then Matlab. Octave and Matlab have similar codes. In some few cases, they have, some variants, but most of the, almost all the codes are the same. So that's what I'm saying, Octave to Matlab. Most of the things that we do in Octave, you can implement them in Matlab. Okay. So let's see about the Octave. This is the outline of what we are going to do today. Now, because it's a video, I don't want to keep too long because that will affect the size of the video. So I'm going to touch on some major things in it. Doesn't mean the others are not major, but then what as beginners of Octave we will need to understand and be able to appreciate so that we can practice it better and get to know the other things. So I'll be talking on the overview, the start quick, getting started, getting help, variables and data types, matrices, plotting, programming, functions, and scripts. And then I will leave you to read on something like files and input outputs, and then miscellaneous, and then other things like Octave and Matlab in practice, and the robotics. So we will focus on these things up to the functions and scripts. The icon for Octave is this one, and then that of Matlab is this. Overview of Octave and Matlab. One thing you have to know about Octave is that it is an open source software, whereas Matlab is not. Matlab, you have to pay before you can get access to the software. That's why I'm actually using Octave. Otherwise, I would have used the Matlab. So everybody can go online, go to www.octave.org, and then you'll get Octave. And if you want Matlab, you have cash and you want to buy, and go to www.mathworks.com, and then you also get the Matlab. And these are the official websites for the two applications. And both of them are high-level languages. And when we say high-level programming languages, we are talking about languages that are closer to human language that humans can easily appreciate. That is high level. And it has these environments. That is the visualization environment. You have the programming and algorithm development environment. You have the numerical computation. These are things that you can use it for. Numerical computation, linear algebra, optimization, and the like. Many things. And even for the Matlab, it has a lot of resources, much more resources than Octave. However, Matlab is a little, when you install the full package, if you don't have a powerful machine, it will slow down your machine a little bit. Octave is lighter than Matlab. Let me put it in that sense. So this is a quick comparison. Matlab. For the purpose of the video, please let me leave these things for you to read. You can easily appreciate the current versions and all that. Please read on them. Save time. Now let's get started. When you are starting Octave, you, as usual, double click on the icon as I showed you, and that will launch Octave. Now I'll demonstrate it for you to see. Launch Octave, and when you get into Octave, it uses a prompt that is Octave, and then each line is numbered. So the first line is Octave 1, and then you have this character looking like a greater than there, waiting for whatever you have to type here. Okay. And if you get into troubles, you type something or anything you want to just get out of that word, you just type or you press Ctrl C to break whatever you are caught up in. And if you want to exit the Octave, you use or you type in the command prompt, like here, you type quit or exit, and then it will unload. It is good to do that to exit it. Matlab to accept these commands. If you want to help at the command prompt, you can type help, and then it will give you some information, or you can type document. It will bring you the documentation, like the help files. And then there are other things that you can also get help on. Many things you can get help with. Let's also look at typing something to get information, especially the commands. For instance, if you want to get help on round, this is a command or is a function, an inbuilt function. Or inbuilt, you may call it inbuilt command or inbuilt function. Round, you want to know what it does. So you say help round, then it will return or to show this, describing what that command does. So it says round towards nearest integer. So you round a number towards the nearest integer. So these are things that you can do to, so as I said, anything that you want to search on, you just type help and then you type the command name, and it will give you information about that. So let's see how we can launch our our Octave, our Octave. So I'll share my desktop. Okay. So when you go to the desktop, when you install the Octave, we have two icons. That is the graphical user interface icon, and then the what we call the console interface. That will give you a black screen, and then you begin to use commands. But we are going to use the graphical user interface. So you double click on this, and then it will open and give you the interface. This is the Octave interface. Let me take you around briefly. We have the menus as usual. Every standard Windows application has menus where we have the new, open, save, and those things, exit. And then we have edit, undo, redo, and other things. Then we have the windows that you can show. So for example, this portion, they are all windows within the bigger window. So that is it. And then we have the current directory, the directory, sorry. The current directory is where when you save something, it will go. If I save a file right now, it will be stored in C users sandbox, the I can change it by coming here and then browsing to any area that I have, or I can even go further to browse for a particular folder. So I can come here and say document. So whatever I'll see will be in document. Or I can even create a folder within this document and use it. So let me choose document. As soon as I choose document, you realize that all the folders in my document are showing here. This area, we call it the file browser. They are showing, and then I can maybe click on particular folder, or I can save into the document. For now, I've not created any special folder. So let me just use the document folder. Now, when you come down here, so let me come here then also. When you come to this page, we call it the command window. This is where you enter all your commands. And so there's a prompt, and this is a prompt having showing the true. You can customize it, showing the true greater than prompt there, meaning it's ready to accept the command. And then we also have to the left hand side the workspace. This workspace shows what we call the classes, the dimensions, values, attributes, and then these are names of variables that we are working with. And then when you come down here, you have command history. Command history gives everything that you have done or you are doing. It keeps records of that. So that if you have done something, let's say yesterday, and then today you want to record a certain command, you can come to the command window and then bring that command onto the command. Bring this from the command history, you can bring it onto the command window and execute it. So if I go through my history, these are some of the things that I've done before. I've plotted graphs, I've done a couple of things long time ago. Okay, that was last year. Okay, all right. So this is basically the environment for Octave. And we have copy, paste, and other toolbar icons for new and all that. Matlab is quite elaborate. Matlab has a lot of facilities than this one. And because this is open source, let me focus on the Octave. For this one, everybody can store. Fine. So this is it. I said earlier on in the slide that if you need help, all you do is to type help and then you hit the enter key. So this is showing where the prompt, the command, we call it the prompt, command prompt, where you type your command and then you enter, and it gives you some information. And then you can also type doc, and then it gives you the documentation. The documentation opens in a tab. You have some tabs down here. You have the command prompt tab, you have the editor tab, this is for programming, and then for creating functions and scripts. And this one is the documentation. So anything that you want to learn in Octave, you can come here and then click on it, and it will give you information about that particular thing. So for example, matrix algebra, I click on it, it gives you information about that. let's go back to our command prompt. For example, if you have, for instance, if you have typed a couple of things and your command window has become, you have a lot of things so messy, you can type CLC, means you want to clear the screen of the command window. So you just click and then everything goes. You can also decide to clear the history. How do you clear history? Just type history and then space and then a dash and C. Then it goes. Right, these are things that you have to learn alongside as we go through. Now let me talk about variables. It's very important, variables and data types. We already know variables and data types in programming. So we are going to use that same idea here. In Matlab, we have three types of structures that you can deal with. We have the matrix, we have the string, and then we have structures. Now, a matrix can be a real number or it can be a complex number. It can be real or complex. String is a matrix of characters. Now, one thing about Octave and the Matlab is that everything is represented, or almost everything is represented by matrix. That is why Matlab, if I ask you right now that what is Matlab, most of you will say mathematics laboratory, but that is wrong. Matlab means, or the full meaning of Matlab is matrix laboratory. You can check it out, matrix laboratory. So everything is in a form of a matrix. If you have a vector is a matrix. That is a column or a row of a matrix. Then a scalar is also a matrix. It's just that a matrix is one by one dimension, one row, one column. We have data types like integers, we have Boolean. Boolean simply means two options, true or false, yes or no, and so here we have yes, a true or false. If it is true, we refer to it as non-null, and then if it is false, it is zero. That's how I see it. But in Matlab has much more data types or other data types that we are not seeing here. And let's get into, we are still under data types, variables and data types. Creating a matrix. In fact, pay much attention to what we are going to do right from here going. Octave handles matrices in a very wonderful way. And that is what I want you to pay attention to. So for instance, if you want to type this matrix or create this matrix, it's very simple. You will type this is the prompt. So you type A is equal to, that is the variable that will store the matrix. And this is the matrix. And use equal to as assignment. You are assigning the matrix to a variable A. And then when you do and you hit the enter key, this is how it will display in Octave. A is equal to, this is the matrix, nicely done. We will get to how to create matrices, so don't worry about that. And then if you are dealing with a string must have quotes, single quotes, and in Octave alone, you can use double quotes. In Matlab, you have to use single quotes. So let's, Octave uses both single quotes and double quotes. The Matlab uses only single quotes. So you type whatever you want to type, and then you assign it to a string variable. This is just the name of the variable, it can be anything, right? And how to create structure. So we have talked about matrices, we talked about matrices, strings, and then we look at structure. We have talked about how a matrix is handled, data is handled, string is also handled. Then we look at structure. For structure, you define the structure of the variable, and a structure can have several parts. It can have an ID, have the name, the time stamp, and all that. I will want to go through this deeply as we move along. A structure can also behave as an array. So you can have the data 1, the data 2, so this data 1, 2. You can also store, you see the structure can store different values if you are using array. So data of 111 can store a particular set of values. Data 222 can store another set of values. Data 33 can store another set of values. And that is the array of a structure. Okay, let's move on. I'll talk extensively on this at a later time. Now, how to display variables. When you store something in a variable and you want to output it or display it, you just type the variable name in the command prompt and hit the enter key, and then you see the output. That is what is stored in the variable. For instance, 4 is stored in A. So when you type A and hit the enter key, you see A is equal to 4. You can also suppress the output by putting a semicolon. So if you type A and you put a semicolon, the output like this will not show. So sign 5. When you type sign 5 and you want to suppress the output, what will come as an output, you just put semicolon and then nothing will show. But normally we use this when you are doing a couple of calculations or manipulations here and there, and you only want, let's say, the final answer to show and not the intermediate processes, and you can suppress the answer. And come to variables have no parameter type. What is the variables have no parameter type? Permanent type. Variables have no permanent type. When you say variables don't have permanent type, it means they can vary with their data types. You can store a number, which is an integer, in a variable s, and then afterwards store a string in it, and then afterwards store another thing. So a variable is a variable. It can vary with its data type. So once you store something, it doesn't mean you can also use it for any other thing. That is why I see it's not permanent. You can change the type of data you assign to it as and when you need it. And if you have a variable and want to know the details about that variable, which we call the scope of the variable, you type or you use the word who. And if you want more details, you use whos. And that will list current variables that you have defined in the Matlab as you use it, and then to give you certain information about it, like the variable attribute name or the variable name, the size. So this is a matrix A, big A or capital A is a matrix, 3 by 3 matrix. It is occupying 72 bytes, and then the class is a double. That is, the data type is a double. we have A, which is a 1 by 1. In other words, it's a scalar taking 8 bytes, and then it's a double in that order. And other things, numerical precision. If you want to vary your numerical precision, we have the real minimum, real maximum, and then the EPS. And these are their range. Okay. And these are other formats. If you want to display your decimal places in a short form, that is 5 digits decimal places, 15 digits decimal places, in that order, you can use the commands. Right. And then these are also some commands or functions, inbuilt functions. We have the seal, we have the floor, we have the round. We have already talked about the round. So the seal will round to the smallest integer, not less than the x that was put there. The floor rounds to the largest integer, not greater than x. And then round, as we have been using, round towards the nearest. And then 6 rounds towards 0. Now let's get into matrices. So simply type. Now, if you want to type a matrix, let's see how we do it. There are 2 ways of doing it. You can either use comma to indicate a column, okay, and then you use semicolon to indicate a row. So if you say 8, 2, 8, 2, semicolon, means this is in the first row, first column, this is in the second column, this is in the third column. And then semicolon means we are moving to the next row. So this will be the first row, second row, third row. I hope you are following. You can also do this same thing by using space. So the 2 are demonstrated down here. We have, and they will give you the same output. 8 space 2 space 1. This is the first row. This is the first column, second column, third column. Then we have the second row, and then we have the third row. So this is a 3 by 3 matrix. Please learn how to. Let me demonstrate this in the Matlab and in the Octave for you to actually see how it works. So I'll go to the Octave. I want to type A, capital A is equal to, then square. Remember to use your square bracket. So 8, comma, let me first of all use the comma 1. 2, comma 1, then semicolon, meaning I'm on the next row. 3, comma, minus, you don't even need to leave spaces. Let me close this space, it will arrange it nicely. Minus 1, comma 4, semicolon, 7, comma 6, comma minus 5. Then I close it with a square bracket. When I'm done, I hit the enter key. And then this is the matrix displaying nicely. That is it. Another way of doing the same thing. A equal to square bracket. This time use space, not comma. So 8 space 2 space 1 semicolon, 3 space minus 1 space 4 semicolon, 7 space 6 put space minus 5. Then I end it with a square bracket. I hate it have the same thing. So this is how we type a matrix, or we create a matrix in Octave. I hope you are following clearly. Right, so let's continue and see other manipulations that we can undertake when we are using Octave. So we move on to that is the output. Now let's also look at how to create a matrix using functions. Again, we have pi is equal to pi. No, remember pi in Octave is a function. So when you type pi, it will return the value of pi as we know. It will return, the string pi. So return its value. So pi is equal to pi squared or divided by 3. Then if you have a matrix, and this one is a rotation matrix, rotation 2 by 2 rotation matrix for transformation. We have cos theta minus sin theta cos theta in a matrix form. You want to type this or create this matrix. That the theta you are using pi on 3. So you can do that by typing it straight away, and then it gives you this matrix. Very flexible when you are working with matrices in Octave in Matlab. Let's also look at some other stuff concerning matrices, creating a matrix from matrices. So you have a particular matrix and you want to create a matrix out of that matrix, or a group of matrices. So here we have 2 matrices. We have A, which is 1, 1, 1, 2, 2, 2. This is the 2 by 3 matrix. And then we have another matrix, 3, 3, and then 3, 3, 33, 33. This is 2 by 1. 2 rows, 1 column. Okay. And we want to create a matrix out of that. So you can just say C, which is the output that you're going to get, is equal to square bracket. Then remember, whenever you put something in a square bracket and then this space, this means this, and then it's column 1, and this will be the next column after this column. So you can put a whole column also as a value of a matrix to create another matrix. So when you do that, this is what you're going to get. So the first portion, which is this 2 by 2, 2 by 3 matrix, will come as the first part of this matrix C, and then space means the next column. So this one, which is the 2 by 1 matrix, will also be appended. So in short, you combine these 2 matrices to form a third matrix, which is a 2 by 4 matrix. Then you can also, we have the A. You can also, create another row. Once you are using semicolon, semicolon means you are moving to the next row. So this matrix, and then the next row means a row down. So when you look at the matrix, actually this is how the matrix, that A matrix looks like, this one, and which is this. And the semicolon, next row, whatever is here will come. So let's look at what we have in here and see if we can manipulate it a little bit. As we want to add a column, and then later on we'll add a row. So let me type something. This is a 3 by 3 matrix. So Let me show you. Okay, so we are here. We are going to also manipulate our matrix in like manner. We have A, so I can say that there's a matrix B, which is the new matrix we are creating out of the A. So I'll say A, that means A will come first. What do I want to do? If I want to add a column to it, then I'll just leave a space, or I can use a comma. Let me use a space. Space means whatever is coming is a column, but then it should match what I have here. So if I'm bringing a column, that column should be, remember, it should be a 3 by 1 matrix. Remember, it should be a 3 by 1 matrix. So I create within that matrix another matrix, which is a 3 by 1 matrix. How do I create that? I want to just add 7, 7, 7, 7. So 7, 3 by 1, so 3 rows, semicolon, 7, semicolon, 7. And I end it. So this is a matrix. I could have assigned this to a variable before bringing it and then bring the variable name here. But I'm putting everything inside already. So we have, and then the matrix. This means that A, which is this matrix, and then I'm appending this 7, 7, 7. So we are going to have 7, 7, 7 here. I hit the enter key. Wow, have it. So this plus 7, 7, 7. I can also add a row down by either using typing the matrix within it or assigning the matrix to another variable and then using the variable name. Let me use the variable name. So I need a 1 by 4 matrix to add a row to this. I'll just say C is equal to a matrix. Let me add 999. So 9. Remember, this is, it should be just one row. So 9. I can use comma or space, remember. 9. So this is one row with 4 columns. I want to fix it down here. So I store it in C. Have it. Then I'll come and say B, which is the new is the matrix that we created here. Okay, before then, let me give a matrix that we will store it in. That's B. So D is equal to our B, which is this matrix. We want to put down here. How are we going to do it? Are we going to use semicolon or we are going to use comma? Yes, think about it. Okay, because this is a row, we are breaking to the next row, we have to use a semicolon. And what are we putting there? I can either put the square bracket 999 as I've typed here, or I can just use the variable name C. Close it and put the enter key. And bingo, this is what we have. Have it done. So it makes it very easy and flexible to manipulate matrices in using Octave and Matlab. Let's go back to our slides. Next thing that we can do. Now here we are going to go into the index. You know, every matrix has index. There are A11, A12, A13, A14, and that's all. And then the index will determine the position of the various elements. So we have, if you want to identify row, remember that row is first. then column follows. It's row by column. So A, I, J, the A is the element at that position. I is the row and J is the column. How do you express this in Matlab? This is how we in Octave. This is how we do it in Octave and Matlab. A of, that is into bracket ij. This will output the element at the ith and jth position. Now, if you want only a row, then you can use the I to specify the row, comma, then colon. This will bring all elements on that row, all elements on the row. And if you want all elements in a column, you can also use colon, and then you specify the column that you want to pick. And then if you want to pick a submatrix out of the bigger matrix, then you can use this. Remember that this is to specify the row and comma. This is to specify the column. So I colon K means a particular I row to a particular K row, and then a particular J column to a particular L column. Don't worry, I'll demonstrate for you to see. So when you do this, it will just pick a sub of the bigger matrix that you are dealing with. That is how. Please get these things very well, because I'll be examining you with them as objectives. I can just give a matrix and ask you to which of the following commands will get this sub-matrix out of the blah blah blah. There are 1,001 questions I can get out of these things. So please pay attention. I'm going to demonstrate some of the things that I've said. But before then, let me proceed to the last one, then I'll do a quick demonstration. Useful indexing command, end. You can also use the command end. And how do we use the end? Assuming you have a matrix called data, which is giving us a row, and then you want to pick something out of it. So vin is 3 colon end, means pick from the third element up to the end. So to pick, you can 1, 2, 3. This is the third element to the end, and then to pick. So this is the output of what we have. Now let me go to Octave and let's try our hands on some of these things and see how it works. So we already have some matrices here. We are going to just play with it. Now, with the matrix A, this matrix, let's identify, or let's output the element at the, when we count the element -1, 1. What will be the position? That will be the second row and then the second column. So that will be 2, 2. Let's see if we can output that. So what we'll do is that we will say we can assign it to a variable, which is small a. Remember, small a is different from big A. Okay. Octave is case sensitive. Let me say this. Octave is case sensitive. And all the variables we are creating, you can see them at the history, and then you can find them at the workspace window. So we are creating, it's telling us the dimension, the matrix, and the values and everything. I'm using small a. So I'll say that A should return 2, 2. means the element on the second row, second column. What are you expecting? I'm expecting -1 to appear. Bingo, have it. -1 is equal to -1. So that is it. Let's say A1. I want the position as this 4. What is the position? Row 2, that is the second row and the third column. So that will give us A of 2, 3, 2, 3. And that will produce or will return the value at that position, which is 4. That's right. So we have it. Now let's also look at how to pick a row, all elements on a row. So if I want to pick, let's say row 1 or row 2 element, let me use R2 to represent row 2. These are variables. You can use any variable as R2 to. I want to pick all the elements on the row 2 in matrix A. So that will be A of, then you specify the row, then use colon. So comma, colon, and you close it. That means pick all. When you use the colon, it means pick all elements in the columns on the row 2. That is what it means. So pump to bring it out. So 3 minus 1, 4. That's what we have here. 3 minus 1, 4. You can also pick a particular column. Let's pick the column 3. So column 3 elements are what? 1, 4, minus 5. This one. So let's do it. C3. I'm using C3. You can use anything. Variable name too. And whatever we will have, we will store in it. So we have A, and then we specify our position, that is column. Remember, all elements in the row, but then we are picking them from column 3. We hit it, and then we have it. 1, 4, and so you see how flexible it is to use Octave to manipulate matrices. You can do so much with it. Now let's also do the submatrix thing. We have matrix D. Let's look at matrix D. It's a 4 by 4 matrix. Let's try and get a matrix, a 3 by 3 matrix out of it. But this time we are going to pick from -1, 4, 7, then 6, -5, 7, 9, 9, 9. We want this submatrix. See where the pointer is. This submatrix. How do we do it? The submatrix, let's call it D. Sorry about that. So it's a matrix that we are getting from matrix D. So first of all, we are picking, remember that to do this from the slides, let's do a quick review of that. Then you can remember how you can go about it. So this is what we are going to do. This is the row and this is the column. So we pick from this row to this row and this column to that column to form our submatrix. So let's go back and do justice to that. So we have, what is the row? The row is starting from row 2 and is ending at row 3. And this one too is starting from column 2 and it's ending at column 3. Okay, so that is column 2 to 3. So it's going to be 2, it's going to be 2 column 3, comma. So from row 2 to row 3, we are putting all the elements and then column 2 to column 3. 2, 3, then you hit the enter key and you will have that submit. Okay, so let's see what we have. Okay. Oh, do you know what I did? So what we did is the result that we said. This is row 2, 2, row, this is row 3. We don't have to count from there. This is actually row, the last one is the 4, the fourth row, because if we start counting from the 1, 2, 3, 4. So because we used 3, it ended at 1, 2, 3, ended here. And this one too ended 1, 2, starting from the 1, 2, 3. The counting is always from the original starting point of the metric. It's not from here. I think that is the oversight that we did and brought us. So if you want to still produce this, because we have to extend it to 2. I even say 2, so which means this is 1, 2. And then I said 3. 3 is this. This is rather 4. So there's a quick way of, using what you have already done and editing it by pressing the arrow key on the keyboard, the up arrow key. When I press it, it will bring the history, the last thing I did in the history, to bring it up. So you see, it brings it. I don't need to type. I'll just do my correction in it. How do I do my correction? Just navigate with the arrow keys. Come and type my 4 here. Type my 4 here. And then I hit the enter key, and I'll have exactly what I want. So that is that. Let's keep going. We have so much we have to do with this. Okay. Then we move on to so these are the things that we talked about, and this is explaining the index. And we can also work with vectors. For instance, if you say 1 to 5, it will return values from 1 up to 5. And then you can, this is if you want to produce a list of values, you can do that by just typing. This one is not a matrix, it's like a list or a vector. However, every one of them is still a matrix. If you want numbers from 1 to 61, however, you want it to be jumping 3, 3, 3. So from 1 you move to 4, you move to 7 in that order. Then you use 1 colon, then the middle one is the step or the incremental value, and 61. So that will return 1, 4. That. So this is an explanation of what we are talking about. A start value, an incremental value in the middle, and then the end value. So that's it. What you get. You can also use the command called line speed command to produce the same. So that this one. So this is what we have. I wish I could demonstrate that. Time safe. Let me move on. You can experiment. You can try it. So but remember, I'll use it along the line. Assigning a row or column. Still on manipulation of matrices. You can, having a matrix, you can decide to assign values to, let's say, row of a matrix. you can change the values in the row, you can update it with another value, or you can even add to it. So for instance, we have this matrix, and then we say A3 colon, comma, colon, and we close the parenthesis equals to minus 3, means at the third row, remember this, the first is the row, and this one means all values in the column in that row. So it means all for row 3, all values column wise should be 3. And then you can also add, if I want to add additional, let's say row, I can also add additional column with a particular value. I can say column 4, even though column 4 doesn't exist in this matrix. Once I bring column 4 and assign something there to add it. So that is what we have. So these two commands will produce or update the original matrix into this. Let me come to Octave and demonstrate that quickly. Let me start with the vector 1. That is, I can say B1 as a variable. Let me scroll up to store this list of vector 1, and then I will put colon there, colon, let's say 10, means I want 1 to 10. I hit the enter key, and here that is step 1. I can also do the same thing. I can overwrite, if I don't change the variable name here, it means I'm overwriting whatever whatever I've already stored. I'm overwriting it with the current one. Let me overwrite it. Assuming I want it to be 2, 2, 2. Then I'll bring 2 to jump 2, 2, 2. I'll do it this way. Starting from 1, the next will go up 3, and that's further. So the last but one should be 9, and then you now have the 10. Then I can extend it to 11 so that we can see that. If I hit it, and then we have 9. The 10th one, it cannot be 10 because we are jumping to 2. So from 1 plus 2, you have 3, plus 2, you have 5, plus 2, you have 8, 5. Yes. So within the range 1 to 10. So I can say 0, B1 equal to 0, colon 0.1, 0.1 or 0.1, okay, and then up to 1. I hit the enter key. It gives me this value. Right. And let's also see how we add to a matrix. So we are going to have, I have matrix. Let me choose one of the matrices that we have already dealt with. Okay, matrix D. I want to change this 9999 to 111. How do I do that? I will, okay, I'll just say the new, let me call that one E. That is E. That will be, remember, it is the 4th row that I'm changing. The 4th row. So I will make it, so in that case, I don't even have to bring a variable here. I just have to make it A, the fourth row, comma, all elements in that row should be equal to what number? I say 1, 1, 1. So 1. So I'm talking about matrix B. Sorry, matrix B. This means I'm changing the 999 here to 1111 by indicating that all elements on the fourth row is equal to 111. So that is it. I can be add more elements to it. And add 555 to it. So D has been updated. I can say D into bracket, and then I'll say 5. I want to add a C to comma C row. And because I don't have 6 rows here to add it to it. If I want to put, what do I put there? 333. Okay. And then I hit the enter key. So it has to that way. In similar vein, you can delete. If you want to delete, you put empty square bracket there. If I want to delete this 333, I'll put there. I can come back and say delete bracket, the 5th row, comma, all elements there should be deleted. Means empty bracket. Then I click the enter key. And it's gone. You can see that here, this was the current matrix, and then I've deleted the 333. You can decide to delete a column, a row, any other thing that you want to. Yeah, so that is what I just demonstrated. Deleting. So with matrices, you can do so much. You will not be able to go through all sorts of times. So much. So this is a summary, getting the size. If you want to know the size of the matrix, these ones I will let you go and try them. So if you have a matrix A, as you have done, if you want to know the size of the row, how many rows are there in that matrix A, you just say size A, then 1. If you want column, then size A 2. That will be the number of columns. And then if you want both, then you can say row and column. And you want to store it in a variable NI and NC respectively. Then you say size A. So the row will be stored in this, and the column will be stored in this. And then if you want to know to get whatever is the bigger number there, the length, you just say length of A. If you want the number of elements in A, if it is 3 by 3, you know you have 9 elements. If you want to know the number of elements, you just say numeral A. And then if you want to check if A is an empty matrix, you use the command is empty, then into bracket A. So please take note of all. You can also do this an alternative, but it works only for Octave. You can say row of A, column, rows of A, columns of A, to return the number of rows, number of columns. Yeah. And then matrix operation, easy manipulating matrices. You know, you understand how we add, multiply matrices in linear algebra and then the algebra that we have done. If you want to use the app, the Octave or Matlab to do it, it is very, very simple to do it. For instance, you can say 3 times A to multiply each element by a scalar 3. If you say A times B plus X minus D, to do this algebraic operation for you nicely. If you want transpose, you say A, then an apostrophe is back. If you want inverse, you say I N V of A. If you want a mixed vector and a matrix, that is, if you want to multiply a vector by a matrix by a vector, this one, positive definite matrices and the rest, you can use it. Check. Okay, type it. Determinant that A, adding value. If you want the adding values, that's the lambda, and then the adding vectors, corresponding adding vectors, you can just do that. V and then lambda. This will split and give you the adding values and their corresponding adding. And then singular value decomposition. This will also give you. We have a lot of things, many more can do. Let's see, vector operations. If you want to do vector operations, you want to multiply a vector, a transpose of a vector by a vector. All these things I wish I'm on the board, I'll write them and then you see the result. A transpose of a vector by this vector will give us a scalar. And then a vector times its transpose this way, in this arrangement, will rather give you a matrix. Let's try some of the things. Okay, then let me finish and I'll try some of them for you to see. And then if you want to multiply two vectors, you get error. Why? Because the dimension, see, for two matrices to be able to multiply, the column dimension of the first matrix should be equal to the row dimension of the second matrix. And because you are multiplying two vectors, this may not be satisfied, and therefore to give you error message. Then we have element-wise operation. The element-wise operation is when you are adding or multiplying element-wise. That is component by component. So if you have two vectors and you are adding, let's say 1, 2, 3, one vector, 4, 5, 6, another vector. So the one will match. So the first position will match the first position on the other matrix in that order. That is what we refer to as the component-wise or element-wise addition, multiplication. Multiplication to be same, division. So in that case, you can divide. If you are dividing the elements component by component in this element by their elements in the other, then you can use this. You can also use this for raised to the power. So you can raise the power 3, meaning every element in it you are raising to the power 3. Okay. So these are also operations that you can do with matrices. We also have useful vector functions. These are vector functions if you want to sum all the vectors, compute the cumulative sum, blah blah. Please, you can go through them. There are plenty. And then here to so functions, if you want to return the smallest value, the maximum value, sort, ascending order, descending order, and the like. Then we also have some special matrices. If you want zero matrix, m by n, then you can just type zeros of, then you put the dimension there. If you want 1, you can also do that. I of n, that will give you an identity matrix of size n. And then diagonal into brackets, we have A, B, C, meaning a diagonal matrix, 3 by 3 matrix with the diagonal A, B, C. You can also do for 4 by 4, 5 by 5, the magic. Magic will give you a matrix, a square matrix that is n by n, depending on the n that you type here, where when you sum all rows and columns, you get the same number. So when you sum all rows, what you get will be equal to when you sum all columns. So that is called magic matrix. Then we also have rounding. This is random numbers, generating random numbers between two numbers. So let's see, 1 and 10, and the like. So these are all functions that you can do with. Let me display some of the things we have just done here for us to see. So in the Octave, and then I will pause and start the plotting of graphs. So let's come to Octave and look at some of the things. I've talked about many things. Some of them you can easily, like finding the size, the number of rows, number of columns. That one you can do it by looking at the commands and operating them. So let me do things like finding the determinant, the index. So if I have D, matrix D should be a square before I can find the 1, 2, 3, 4. Or then 1, 2, 3, 4 by 4. So all that I need to do is to say, let me store it into D, small d. I'll say depth of D, in the determinant of D. So this is the determinant. I'll say D1. So say of D, in the index C. And I can say it's a V square bracket V is lambda. So it will give me the eigenvalues of D. I put the index here. And it gives me the eigenvalues. The eigenvalues are the values at the diagonal. And these are the corresponding eigenvectors. So when you put this eigenvalue, these are the eigenvectors. Take this one, these are the eigenvectors. Take this one, that one. So it's very easy, manipulating matrices. Very easy. Let's just look at some vectors and what they will do. So now we have a vector and create this vector. 1, 2, 3. That's one vector. And remember, this is going to be a column vector. This is I say a column vector. This is a row vector. Let me make it a column vector. I'll make it column vector. Column vector will mean this one to be okay. So this will be a column vector. Yeah, column vector. Then I can find its transpose. The transpose of this will be taking tab and the transpose. So I've transposed. Remember, because I didn't assign it to any variable, so it's using answer as a default variable. And if I want to multiply these two matrices, is it possible? multiply, because the column is row by column. So if I'm making x times x star in this way, then this row, one row, this one is going to be this one against this. And then this one won't get anything. So it's over. But then if I make it this by this, that one is work. Because it will be this against this against. So you see, and that will give us a scalar. So that is what we talked about on the slide 29. We have x times x. This one times this one to give us a scalar 14. And then we can also have this. Okay, so if you are doing this by, okay, that one will give us a 3 by 3 matrix plus this row 1, row by column. So there's only one element here to go with it. Then we are done with it. Then this one to go with it, and this one too. So we are going to have, let's see and see what is x by x transpose x by x transpose. That will give us the matrix. Yeah. So you can do the manual multiplication and then I go. And then if you want to multiply x by itself, it will not work. And this one, it's working because the column dimension of this matrix, of the first matrix X, matches the row dimension. So that's why we are getting. If you want to multiply this by itself, x by x, it will not work because the dimensions are not. So, and then we also talked about. Okay, let's look at the special matrix. I want matrix, let's say A. I'm overwriting the A already. A to be zero matrix. So I say zeros, zeros into bracket. What is the dimension? It's a 3 by 4. It doesn't need to be square. And I hit it, I'll get a zero matrix. If I want 1, 1, 1 matrix, let me use B. So 1. I want to dimension. It is 8 by 8. To produce matrix with entries 1, 1, 1, 1. Identity matrix. Let me call it I. So I get the I. And what's the dimension? Because it's a square matrix, it doesn't give you row and column. It must be a square matrix. So it's the identity matrix of n by 10. And I'm happy. Once you do, I want a diagonal matrix. Let me call it C. So I say diag into bracket. Then the elements I want to put at the diagonal. I want to put 3, 6, 9. Oh, let me see. Okay, 9, 6, minus 2, 2, 5, 6. So once I'm using space, I don't need commas. I can either use comma or space. I'm using space. I don't need comma. And then 1. Now, what do you think would be the size of the diagonal matrix? Then I have to close the parenthesis. It is going to be 1, 2, 3, 4, 5. Yes, 5 by 5 matrix with the diagonal being these elements. That's it, that's all. So when it comes to matrices, you can manipulate it in so many ways using the Octave application or Matlab. The last one I'll do, and I'll move on, will be magic. So let me call it M equal to magic, and I can give it any dimension, let's say 4. And that will mean that when you sum this, you sum all the rows and you sum all the columns, you get the same. You can try something. You can try sum all the rows, sum all the columns, and compare. Get the same. All right. So we have at least gone through a couple of things. Random numbers. You can give me a random number. If you R is equal to one random numbers between 1 and 10 or 20. About 20. Let's select random numbers. Yes, yes. Okay. Okay. There's something I need to talk about. The random number generator rather will generate 20 numbers between 1, 0 and 1. Rather, that is the command that between 0 and 1. Between 0 and 1. That's how come they have the values between 0 and 1. So 20 numbers, uh, 20 numbers generated 0, 1. Okay. Let me move on to the next thing. So the next thing we look at is matrix, multi-dimensional matrix. That is this time 3-dimensional matrices and the like. So there's a quick example of 3-dimensional matrix. I'm just explaining it. I wish I had a board and then I'm explaining that for you to look at it. And ordinarily, we'd have said 2, comma 5, and that's a 2 by 2. So 2, comma 5, comma 2 means 3 dimensions. But for the purposes of the video, let me skip this and then I want you to read on it. All right. So these are some of the things that you have to know about metrics. There are a lot. Please make time and read about them. So I'll end this lecture on how matrices are handled using. Okay, thank you very much for following this lecture.